Attention is all you need. This is the research paper released by Google that changed everything and gave rise to all the LLMs and GPTs that we work with, right? So earlier, to predict and understand language, we were using advanced RNNs that had a lot of limitations. They keep forgetting things in a longer data set. They were very slow to train. But this paper gave rise to a new concept of transformers and attention mechanism. In simple words, given a sentence, using the attention mechanism, a transfer figures out how are words related to each other in terms of position, meaning, and importance. Now this is how it works. Now given a sentence, a transformer divides it into different tokens. Tokens are the smallest unit that a transformer can understand. It can be a small word or a syllable or some prefix or suffix. To make things simple, let's take it as a word. After dividing the words, each word is given an ID. This is like the position of that word in the vocabulary of all the possible words in our dataset. If my dataset contains 26 letters, then the ID for C would be 2. Now each token ID is mapped to a token vector embedding, which is generally a list of 512 integers. You can think of them as 512 weights that define the meaning of that particular word. Initially, these weights are randomized and are updated while data is trained. Thing to note is that if two similar words are there in a sentence, their vector embeddings will always be the same. Next, we calculate the positional encoding. This is basically another vector embedding of 512 weights that defines how a word is positioned in a sentence. This is calculated using this formula, and generally, no two words have same positional encoding. Now, final input embedding is created, which is the vector sum of the token embedding and positional embedding, and then it is fed into a transformer. A transformer has attention mechanism, which are made up of three things: query, key, and value. Now, key is the label that any token carries. Value is the meaning or that information of that token, and query is the question that you are asking. It could be how are these words related to each other, which is the most important word, or maybe which is the next word in this prediction. A very simple example is if we have a key value pair of genres in movies. For example, we have key as love and value as Titanic, and key as horror and value as Annabella. And the query is to find out love. Then the dot product of love and romance would be higher than the dot product of love and horror. So we can say that the weights of love are more closely related to the weights of Titanic rather than the weights of Annabelle. So in terms of love, Titanic gets more attention than Annabelle. Now in a similar way, attention of each word is calculated with every other word in a sentence. This helps us figure out how important each word is to the other word. Now since the goal of creating GPT is to generate the next possible word, while calculating attention for a particular word, we only give importance to words that are before them and not after. Now this is called self-attention, and it works on smaller sentences. But when the data size gets bigger and sentences converts into paragraphs or essays, same words start having different meanings, attentions, and importance in different sections of the dataset. So to solve this problem of huge dataset, we use multi-headed attention, which is what is exactly used in a transformer. So in multi-headed attention, we divide a long textual data into smaller sections and figure out the local self-attentions of the words in those particular sections. And finally, these local self-attentions are combined to create a multi-headed attention for each token in a huge dataset, just to give computers an illusion of understanding the language and figuring out the next word.